machine tool gearboxes. Yesterday we studied reduction gearbox. Machine tool gearbox is also reduction gearbox. Okay, but the difference is in yesterday's gearbox, that is reduction gearbox, how many input speeds were there? Input speeds. One. Motor was the input and it was running at constant speed. How many output speeds? Motor, gearbox and then output. So it was only one speed. But after reduction you get that speed. वो speed आपको कब मिलता है? After reduction. Okay, in this case also in machine tools we require gearbox, but the output speeds are many speeds. What is the difference? At the output you get multiple speeds. So these gearboxes are called as multiple speeds gearboxes. As an example, you know lathe machine.
Yes.
Everyone knows.
Yes.
In lathe machine, do you vary the speed of the spindle?
Yes.
Speed of the chuck?
Yes.
How it is varied? There is one knob. By changing that knob, you can get different speeds at the output. But is there different speeds at the input? At input, are there different speeds? There is only one motor. Okay, so with one input speed, you get multiple output speeds. Okay, and such requirement is there for different machine tools like lathe or some other machines. Okay, so machine tool gearboxes in which there are we have to design different drives at variable speed range. So you get at the output different speeds. Okay. Now in this particular unit we will study structural formula, then structural diagram, ray diagram. These are the contents of this particular unit. Okay. Then speed chart. Sorry. Okay. So these are the contents of this particular unit. Now as an example, in lathe, shaping, milling, drilling, okay, we need to have different speeds at the output. Okay, so it is achieved by using, what is this? Achieved by using gearbox. Okay, though there is only one speed at the input. Input pe motor runs at only one speed, but at the output you get variable speeds. We get different speeds by using gearbox. Okay, so that is multi-speed gearbox. कल हमने जो स्टडी किया था वो कौन सा gearbox था? Single speed. It was single speed reduction gearbox. Now we are going to study multi-speed reduction gearbox. Okay, so that is the difference now. You might have seen such arrangement. Okay, there are many gears on one shaft, many gears on counter shaft, and many gears on the output shaft. So just by varying these or engaging different pairs at the output, we get different speeds. Okay. So here there is single input speed. Input speed is single, which is supplied by motor. Okay. At the output we get multi speeds. Okay. On the spindle where we mount our workpiece. Okay, so at the output we get multiple speeds. So there may be number of speeds like N1, N2 up to Nz. So henceforth we will use term Z for number of speeds. So extreme spindle speeds are, if N1 is the minimum speed or Nmin is the minimum speed, there will be maximum speed which is Nmax. Speeds will vary between Nmin to Nmax in different steps, and those steps are denoted by Z. Okay, I'll give you later on whatever is the required part. So here there is minimum speed and there is maximum speed Nmax. Okay, for Nmax we also use Nz because Z is number of steps. Okay, now why do we require multiple speeds? The reason is here. Okay, why it is required? To get different speeds. Feed and depth of cut. There are two terms. Feed and what is the second term? Different depth of cut. Okay. So this is a workpiece and this is a tool. This is workpiece. The motion parallel to the axis is called as feed, and motion perpendicular is called as depth of cut. I think I told you different. So this is depth of cut, this is feed. Okay, so to achieve different feed, to achieve different depth of cut, also to machine different workpiece materials, we need to change the speed. Also to achieve different diameters, different diameter of the workpiece, we need to change the speed. So this is the requirement that we have to go for multi-speed gearbox. I hope you understood this. Multiple speed gearbox का पाहिजे? Why it is required? Okay, it is required because we have to, for depending upon material, depending upon conditions, we have to use different feeds, different depth of cut. Some material may be soft material that may not require much depth of cut. Some materials are hard materials, they may require large, small depth of cut. Okay, so accordingly we have to vary the speed of the spindle. The speed at which spindle rotates, and how it is achieved? It is achieved by varying speeds of the spindle using multiple speed gearbox. Okay, step and stepless. As the name says, step means speeds are in steps. That means if N1 is say 100 RPM, you can directly go to say 150 RPM. This is called as step. And if you get all the speeds in between 100 and 150, that is called as stepless. There is no step. All the speeds between the two speeds can be obtained. That regulation is called as stepless regulation, which can be achieved by using variable diameter pulleys. Okay, pulley of variable means this what we can say, increasing or decreasing diameter pulley can be used to get stepless regulation. And how to get step regulation? By using gearbox. So in this case you can see by engaging different gears. If this gear engages with this gear, you get different speed at the output. If this gear engages with its counter gear, then you get different speed. We'll see later on how it can be achieved. So by just engaging different pairs, you can get variable speeds at the output, and that speed will be in the form of discrete steps. Hence it is called as step regulation.